Welcome to solverfy.
To start this problem, let's look at what's given in the question. First, we're given the intensity of the light source, which is 1 times 10 to the minus 3 watts per meter squared. We're also given the distance, which is 33 centimeters. So to convert that to meters, you divide by 100, and you get 0.33 meters. In part A, wants us to find total energy. Before we do that, let's look at the units for intensity, which is watts divided by a meter squared. Well, we have intensity, we have meter squared, we have meters, so we just square it. So let's solve for watts. Or watts is simply power, so P is equal to intensity times meter squared. Now plug in our numbers. For intensity, we have 1 times 10 to the minus 3 times our meters, 0.33 meters squared. So for power, we get 1.08 times 10 to the minus 4 watts. Well, looking at watts, the equation for watts is really energy divided by time. Well, we have watts, we have the power, we have time. Time is given as 4 hours, and if we convert 4 hours to seconds, we have 14,400 seconds. So let's solve that equation for energy. Let's call it capital E. We get energy is equal to watts, which is power, times time. Plug in our numbers. 1.08 times 10 to the minus 4 times time, which is 14,400 seconds. So energy, total energy for part A is equal to 1.57 joules. Now part B wants us to find the electric field and the magnetic field. So let's look at the equation for average intensity, which is I is equal to 1/2 epsilon naught permittivity of free space, which is a constant value, and the speed of light c times the electric field squared. So now solve for this electric field. To do that, you multiply both sides by 2. To get rid of E naught and C, you divide both sides by E naught and C. And then to get rid of the squared, you square root both sides. So for the electric field, we get 2 times the intensity divided by epsilon naught and the speed of light, and all of that to the square root. Plugging in our numbers, 2 times 1 times 10 to the minus 3 for intensity, which is given in the question, divided by epsilon naught, constant value, 8.85 times 10 to the minus 12, times the speed of light, c, which is 3 times 10 to the 8th, all of that, square root. So for part B, the electric field is 0.88 volts per meter. Now that we have the electric field, it's easy to find the magnetic field because we know the speed of light is a ratio of the electric field and the magnetic field. Solve for the magnetic field, and you get E naught, the electric field, divided by the speed of light. Plug in our numbers, which is 0.88 for the electric field, divided by 3 times 10 to the 8th for the speed of light. And finally, our magnetic field, B naught, is equal to 2.9 times 10 to the minus 9 teslas.